Today we're going to be talking about radicals. This right here is a radical, also known for this one a square root. Okay, the parts you need to know about it: the big shape part of it is a radical. That's what we call that. The number inside is a radicand. So the radical of 25, or the square root of 25, is equal to 5. Okay, I expect you guys to know that by now, because that is one of the perfect squares, which we have here, a list of them. All these are the perfect squares of numbers that you should probably know by now. So if you're looking through those, make sure you should know all those, just be on the safe side. Radicals are really important and do a lot of things for us. So first of all, when we have multiple things in our radical right here, we're going to do the operations inside of here first. So you type in your calculator 256 divided by 4. You should figure that out. That is equal to 64. But that is still in the square root, the radical. But the square root of 64, hopefully you should know by now, is just 8. The same thing of 40 plus 9, that is the square root of 49, which, as you should know as well, is 7. Okay, try this one out on your own if you want to figure it out. We can tell you what the answer is here in a little bit, or ask in class. You can also do things with multiple radicals. So like right here, I've got a 2 squared root 7 times, and there's a number here, so we're going to assume it's a 1 square root of 5. So when you multiply them, you take the outside numbers, 2 times 1, and multiply them together, and get a 2. And then you take your inside numbers, 7 times 5, and we get a 2 square root of 35. Okay, over here we have a 5 times 4. We have a 20, and then square root of 3 times the square root of 5 is equal to the square root of 15. Over here, division, make sure you divide 55 and 11 first, do that together, and that should equal 5, so 22 square root of 5. Now the key thing about this right now is how do we simplify it down even more. Your simplified radical form is when it has no perfect squares in it, and there are no radicals in the denominator. This will be a big thing coming up later. You have to have that. So let's just do square root of 20. So square root of 20 is broken down easily into equivalents 4 and 5. 5 is a prime number, can't break down anymore. 4 can be broken down into 2 and 5. This is the prime factors of this. Our goal is to look for groups of 2 of the same thing. So I have 2 2's right here. Okay, we're going to pair them up. They're going to go outside together on the town. So we have a group of 2's coming out here. The key thing is there's only one of them will ever come out here. I don't have 2 2's here. I just have 1. Anytime I have a circling up group of 1, one of those numbers comes out. This 5 does not have a friend to go along with it. I box him up, he's staying in for the night, he's not going out. So what we had for our answer was a 2 on the outside, and then a 5 stayed on the inside. 5 is a prime number, I cannot break that down anymore. This would be my final answer. Let's make it a little more fun. Let's talk about this negative 6 squared root of 125. So we break down 125 into 25 and 5. We break the 5 down into, or 25 into 5 and 5. Once again, we're looking for groupings of 2 things. Well, here's 2 5's right here. You're going to be saying, oh, there's a third one right here. Well, you have to be in groups of 2. So we box this one in. So how many of these 5's will always get out? Just 1. So take that 5. He's going to come out here with that negative 6. This 5 is on the outside. I have a jail story if anybody wants to come talk to me about it, of how to remember it in a different way, but that's how I do it. So negative 6 times this 5 that's coming out is negative 30. And then on the inside, I have a square root of that last number left, which is just 5. All right. And if you have any questions, come make sure you ask us in class.